All right. Good morning, good evening, everyone, wherever you are from. Uh, okay, so this is gonna be one of the lengthiest session where we'll be continuously discussing and practicing everything about database architecture, database concept, and database administration. So again, in the meantime, while I'm explaining, going through all the concept, whatever I'm planned for today, you can feel free to uh, post your questions here in the chat, or you can ask the question. You can unmute yourself and you can ask the question. Make it so interactive so that it will be interesting for everyone. Rather than if I simply teaching, you're listening, that not gonna help or not gonna add more value addition. Rather, I request this session has to be so interactive because we're gonna extend it for next 3 hours. In between, we can take a short break, but yeah, let's get started. So, as it says, it's a Oracle DBA workshop. Here, I'm restricting this to only standalone database. We're not going to talk about anything on the rack. Provided if there is any questions around the rack or comparison between the database and rack, we can take up those questions. And also, if any of you have faced any interview questions and you're not able to answer those kind of questions, you can just feel free to post those questions and I can take it. Right, with that, let's get started here now. Very first thing, what exactly mean by database architecture and how this Oracle database architecture is different from the other databases, and how this Oracle standalone database architecture is different than uh, RAC architecture. We'll first do a basic check and then we will go further. Um, Very first thing, let's say you can compare with the other database technologies. Other DBs, let's take it as a DB2, IBM DB2, or SAP HANA, or MS SQL, or PostgreSQL, or maybe MongoDB, or any other database. If they, if you think of their architecture, they will be having an instance and single instance mapped with multiple databases. Meaning, let's say I have this server. Let's say this is your lab one. In this lab one, they're going to set up an instance. Once they set up instance, they can create multiple databases. Let's say your production database, test database, UAT database, or any kind of databases. So if anyone, a DBA who can connect to this instance, he can manage all the databases underlining whatever configured on that instance. That's a typical other database architecture, how it looks like. Whereas when it comes to Oracle, it will be an instance, a single instance. My bad, that's the typo. Right, single instance mapped with a single database. Here it is a one-to-one mapping. When it comes to Oracle, let's say same concept. You have a lab one, and then if you configure with your instance, and then that instance is mapped with the one particular database. It's always one-to-one. Can I run multiple databases, development database, test database, UA database? No, Oracle will not support that. It'll always one-to-one mapping. So advantages here with the I'm talking about these other DBs, and here it's a Oracle DBs. So here with the advantages for the other DBs, from one single instance, we can manage multiple DBs. But where with the Oracle databases, if you want to manage your database one, you have to connect to that instance one. If you have a test database, you want to manage that test database, you have to connect to that test instance. You have UAT database, you want to manage that, you have to connect to UAT instance. That's a simple comparison between the other database and Oracle database. So then Oracle has came up with a new concept called a multi-tenant architecture. Right? What is this Oracle multi-tenant architecture, which is came in 12C onwards? So what exactly mean by this multi-tenant architecture? If I compare side by side, this is your lab one. For other databases, they have this instance, and this instance is mapped with the multiple databases. For the Oracle traditional architecture, again lab one. So they're going to configure instance one, and that instance is mapped to one database. Again, if you configure one more instance, and then you can map that onto one more database. So as long as this lab has enough resource, memory, RAM, CPU, you can configure multiple instances and multiple databases on that single server. But in order to manage that one, let's say this is your development database, and this is your test database, and this is your UAT database. Same way here, this is my development database, and this is my test database. So if I want to manage my development database, I need to connect to my development instance and manage it. If I want to manage my test instances, I need to connect to my test database. I need to connect the test instance and manage that. Whereas in the other database architecture, I just connect to one instance which is running here in this lab one. I can manage any one of this database. That's fine. But with this now new concept in Oracle 12C multi-tenant architecture, what Oracle has come up with, Oracle maintained this fundamental architecture, meaning that's the same concept. Lab one. So let's go ahead and create an instance. And on that instance, you can go ahead and create your database. So inside the database, you can create something called virtual database. These are called as the PDBs, pluggable databases. And this main database, one instance and one database, this main database is called, this is CDB database, container database. This container database internally contains this multiple virtual databases called PDBs. So you can create this PDB called development. You can create this PDB called test. You can create this PDB called UAT and whatever pre-prod. Like whatever here, like other databases, how they used to maintain architecture. A DBA can connect to this instance. He can manage any of this database. Same way here, DBA can connect to this instance here in this multi-tenant architecture, and he can manage this particular CDB database. Once you manage these CDB databases, that's more than enough. Underlining all your pluggable databases will be automatically managed by the CDB. Or if you particularly want to manage your development database, you can connect to this via this instance. You can connect to this development database and you can manage it. But that's where the management becomes so easy when it comes to multi-tenant architecture. So the introduction of this new architecture in 12C, that will be a CDB and PDB. CDB stands for container database, PDB stands for pluggable databases. So that is your quick comparison between your other database versus Oracle database. On Oracle database, you have this normal database and you have this multi-tenant architecture. This normal database architecture is a day one concept from Oracle side, from 7, 8i, 9i, 10G, 11G, 12C, 18C, 19C. So in 12C, it's like this. Okay, now we can make it as a normal DB architecture, and then multi-tenant database architecture. So this normal database architecture, let's say, which came in Oracle 7 or 8i or 9i or 10G or 11G and 11G. So this multi-tenant architecture came in 12C. So in this particular new concept came here, and in 12C or 18C and 19C, Oracle has given option. If you are installing your database with a 12C or 18C or 19C, Oracle has given option 1 and then option 2. While installation of your database, you can create a normal database architecture, or while creation of your database, you can choose this option 2, multi-tenant architecture in these three versions. And post 19C, Oracle has released 21C, and post that 23 AI, and post that 26 AI. On these versions, it's only option 2. There's no more option of 1, normal database. From 21 share notes, Oracle highly recommended. There's no more normal database concept or architecture. You have to always go with the multi-tenant architecture. Right? So it's a DBA responsibility. So DBA has to be adapt to this multi-tenant architecture and move ahead with that one. And you have to learn that one. Right? We'll discuss that multi-tenant architecture in a minute. But yeah, I just want to give this comparison between the other database sources and Oracle database. Now this concept is okay. The very first one what we talked, other DBs versus Oracle. And the second concept what we talked here, normal DB architecture versus multi-tenant architecture in Oracle. Right, now next one. Now we got the simple gist or understanding of database in Oracle, either normal or multi-tenant. And then in the same concept, if you go with types of Oracle DBs. So in a straightforward, standalone and RAC. That's what Oracle offers you. A standalone normal database, standalone multi-tenant database, RAC normal database, RAC multi-tenant database. It may be anything. The standalone and RAC, that's two types of databases what they get. In this standalone, where you are going to install your database? Let's say standalone in OS file system. OS file system may be anything. Maybe let's say your OS file system or NFS or SAN storage or NAS storage, etc. Let's say you have a server. Let's say what I mean, I have this lab 1. So you want to create this standalone database. For this lab 1, let's say you attach some storage here. Again, if anyone from the storage background or Linux background, they'll understand what exactly mean by storage. So default, when you install this OS will comes with the OS file system, OS storage. For that OS storage, if you attach NFS, you attach your SAN, you attach your NAS or anything, any storage type you attach it. So that will be a storage attached to that server. So first that you can install your database instance, and associated to that database can run it on that OS storage, or that database can run it on that any of the attached storage. Right, underlining it is a database running with the OS storage. That OS storage may be anything, NAS, SAN, NFS, or whatever the storage attached to that one. Or there is a other type of standalone database. Standalone in ASM file system. ASM is the Oracle provided storage. ASM stands for your you can think of whatever your storage device here, NFS, NAS, SAN, whatever the your storage admin is going to provide you storage and attach it to that Linux server. Instead of that storage admin going to provide your storage, as a DBA, I can provide my own storage. This is provided by your Oracle. ASM stands for Automatic Storage Management. You can just think of it as storage. At DBA, we are going to provision the storage by our own. We no need to depend upon Linux admin or the storage admin. So I can create, let's say for the same server, I can have my ASM storage. I can create my ASM storage and attach it to this server. So when I install this instance, for this instance, I can run my database over here. Right. So that is where Oracle will highly recommend you to run your database on a standalone server only with the ASM so that you can get a lot of benefits because it's a ASM storage and it's a ASM instance. So Oracle, this is Oracle storage and the database also belongs to Oracle and they know how Oracle IO interaction works. So even if you run database with a standalone, run it on ASM, not on OS file system. Even if you run it Oracle database as a RAC, run it on ASM. Right, again here RAC database or RAC one node database. In RAC, we have two types, RAC database and RAC one node. But again, where you want to run your database? You want to run it on ASM storage or NFS storage or anything, maybe SAN, NAS, all will be applicable here. Right, in the RAC, we have RAC database and RAC one node database. And again, you can build your RAC database as a RAC database and RAC one node database on ASM or on NFS or SAN NAS. You can build your RAC one node database on ASM or NFS storage. Everything is applicable here. But even if you run database as a standalone, whether you run database as a RAC, always run it on ASM storage so that you can get a lot of IO benefits. All right. With that, now we got to know other database structure, our Oracle database structure, and in Oracle, normal database and multi-tenant database. And again, in Oracle itself, what are the different types of databases and what Oracle recommends you to run it on ASM storage. So now let's stick to Oracle architecture only. For especially standalone, this entire course will be based upon standalone. I'm not going to touch anything on the rack, but more than that, if you have any questions, you can feel free to ask me or ping it in the chat here. I'll take it out. I already have one question here. Majid is asking, can we also plan for rack? Yes, definitely in upcoming days. I will host one more 3 hours live sessions for the rack only. So rack database, we can talk more on the rack concept and rack networking and rack administration, so much stuff in that. But now let's concentrate only on the standalone database. So far, whatever I talked here, I talked about two words repeatedly. One is instance and one is database. That's where your database architecture comes into picture. The moment somebody asked you, or it is one of your common interview questions in any interview you can attend, what is database architecture? Or they may ask you, can you brief a database architecture? Or can you explain or brief Oracle architecture? Whatever question it may be. Database architecture, Oracle architecture, if they ask you. So again, same concept. It will be a combination of your instance and database. Whatever we so far talked. In any Linux server, you'll be having instance and you'll be having database. Combination of those two will make you entire Oracle architecture or Oracle database architecture or your database architecture. Instance and database. And what is this instance and what is this database? Instance is your logical structure and database is your physical structure. The moment you install your database here on a server, which is going to form a logical structure. The moment I say logical, you don't see it physically. It's like your processor or your memory, which is logical concept. You cannot physically go and then check them, or you cannot see that one that is already the physically exist. So instance your logical structure and database is a physical structure. So your physical structure, let's say your instance, I say logical, and then what is the consist of? What exactly it is made up of? Your instance is a logical structure which is made up of memory and background process. And then if you say, what are the memory parts inside that? Inside that memory, you have SGA and PGA. And what are the parts of that background process? The background process is mandatory background process and non-mandatory background process. So again, if you further go inside SGA, you have so many sub-memory components. Inside SGA, you have buffer cache, log buffer cache, shared pool. Inside shared pool, you have library cache and dictionary cache. In the buffer pool, you have a keep pool, recycle pool, and NK buffer pool, and so many things. That's your SGA. And PGA, SGA stands for your shared global area or system global area. PGA stands for your program global area or private global area. So inside PGA again, you have so many sub-memory components. Stack space, bitmap, bit-tree area, sort area, cursor area, temp area, UGA, so many things. And then that is your instance. Instance is a combination of memory and background process. That memory is made up of SGA and PGA, and that SGA and PGA internally have so many sub-memory components. And again, instance is made up of logical structure, memory, and background process. That background process has mandatory and non-mandatory background process. If I list out few of them as a quick example here, mandatory background process, your PMON, SMON, checkpoint, log writer, DB writer. Non-mandatory background process are archiver, MON, MNLL, recover, etc. So let's say now the question comes. Okay, before I go into that question, what we talked here now, it's all about combination of your instance, logical structure, memory, and background process. But your architecture is the instance plus database. What is the database? Database is your physical structure. What is that physical structure meaning? The data files. The data files are the storage files, are the end user data, or the backend files, or the application data, whatever the end user is going to store the data. Those are physically stored under your OS file system or ASM file system. Go back here. Your database may be running under OS or ASM file system. Your RAC database may be running under ASM or OS file system. So physically, you're going to store those data. Those are your database. Right, and then now question comes here, whatever the question what I wanted to talk. Okay, now I have this server, this lab1 server. Let's say this lab1, any server you build, Linux or Windows, which will be comes up with a memory and then storage. Let's say this lab1 has 20 GB RAM and it has 100 GB storage. So how many database and how many database instances I can run on this server? Based upon how much instance you're going to allocate the memory. Let's go back here. Your Oracle architecture is a combination of instance and database. Instance is a logical structure made up of memory and background process. Background process are your OS process. You can leave that one. Memory. You're going to assign this instance how much memory you want it. Let's say I'm going to assign this instance with the, let's say 8 GB. The moment I assign 8 GB, this server has 20 GB memory. Out of that, I assign 8 GB. And then the moment I create this database, default, this database is going to store the data files here. Database is nothing but physical files or the data files. So default any database you create, which will be get created with the system, syssox, user, undo, temp, default data files. And then your database maybe typically default will be of 3 GB storage. Right now this server has 100 GB. And then out of 100 GB, if you take 3 GB, 97 GB is storage free in this server. And then out of 20 GB, 8 GB memory went, it has the remaining 12 GB. So let's go and then I can create one more instance. And then I can create one more database. Let's say I can create one more 8 GB instance. And then another 3 GB database will be created here. So 3 GB plus 3 GB, totally 6 GB is total storage utilized out of this 100 GB. So remaining whatever 94 GB is free. And then 8 GB plus 8 GB, 16 GB is gone. Remaining 4 GB. That's 4 GB I needed for my lab server operations. If I continuously consume all the 20 GB RAM, the server itself will crash. Now I created two databases. Let's say it's a dev database. Let's take it's a test database. So now I got a request. I can create the from the business or application side. I want one more database called UAT. So I don't have any much resource here. I have storage, but I don't have a memory. Then I can engage Linux admin. Boss, can you increase the memory? The Linux admin will add one more 10 GB RAM. It becomes 30 GB. Now I can go ahead and create one more instance, UAT instance. Again 8 GB and then again 3 GB. So 8 plus 8 plus 8. Now the server has 30 GB. So I'm using only 8, 8, 8. 24 GB is gone. So remaining 6 GB is free now. So this is how you can calculate or you can say that I don't have any restriction on a server, on a given server. I can create n number of databases as long as that server has enough resources, memory and RAM, or even it comes to CPU.
Sorry to interrupt you, Mallikarjun.
Yep.
Yeah, my question is that how we will extend this memory database?
I'll talk about that. I never talked about this memory increasing. Here, this is server memory increasing. Your Linux admin will tell you, okay, my intention is I need to create a new database. For that new database, do I have enough RAM here? If I have, I can go ahead and create it. If I don't have enough RAM on the server, I can engage Linux admin. Linux admin will increase it to. So now fine. Now we had 30 GB RAM, and then my business requirement is to create these three databases, dev, test, and UAT. Created three databases. Fair enough, everything runs fine. You see, as of today, my business is going good. My three databases are running fine on this lab one. And now let's say after 1 month, a lot of activities are done by my developers, a lot of activities are done by my testing team, a lot of activities are done by my UAT team, and a lot of end users are connected, a lot of end users are doing a lot of transactions, and then they're putting a lot of data inside my database. Let's say I'll take only one example. Let's take UAT example. This development and test, it's internal use, nothing happened there. Let's say this is my UAT, all the end users are connected, and any user, let's say client 1, client 2, client 3, any of them want to connect to my database is here and my instance is here. My client 1 want to connect to database and access the data or access the table, or my client 1 want to create a table called employee table. Let's say employee table with the employee ID, employee name and salary. Employee ID 1, employee name is A, employee salary is 1000. My client 1 want to connect, he has to connect to instance only. Once he connect to instance, he can create this table. Once he create this table, that table will be stored under this data file here, physical files. In the under this user data file, that whatever the employee table is going to create, that table will be stored under this data file. My client 2 want to connect, again he has to connect to instance and he has to read that table or insert the table or whatever operation these clients or end user has to do, they have to do it on the instance level. And via instance level, the transactions will go to your database. Or client want to read the data, he has to connect to instance Via instance, he has to read data. Read data will be comes from your data file to your instance, and then it's gonna go to end users. So as of today, three databases are using 8 GB, 8 GB, 8 GB, and then all of them are database size is 3 GB, 3 GB, 3 GB. You considering this U8 database, the client one who was connected to my database has created a table called employee. He's inserted around 100 million records. That 100 million records uses around 50 GB of storage. The client one connected to my database and he inserted this 100 million records. All those 100 million records will go to your database and they'll all store under this user data file. So your database size will keep on growing now. It was 3 GB earlier. Now that guy has inserted more record and 150 GB data got increased. Now your database size is 50 GB plus 3 GB, 53 GB total database size. That's fine. Your database is keep on growing as and when users are inserting the data into your database. Now it's only three users are connecting and your instance, all of them are connecting to instance. They cannot directly connect to your database and read the data. They have to connect to instance and via that instance, they have to do that whatever operation they want, insert, update, delete or whatever. As of now, three users are connecting. Like maybe after a month, these three users become 100 users. My business is growing and now the 100 users are all connecting to my instance. And then I have instance with only 8 GB. Is that 8 GB enough to support those 100 users connections? No. This 8 GB is max. I can say, let's say, uh, I'm giving a rough example, not accurate one. This 8 GB is able to handle only 50 users. Now the 100 users are able to connect to my database. So that time my instance will get crash or my database will hang. So that's where the DBA job will come. Okay, now my business is growing, a lot of users are connecting. So this 8 GB RAM is not enough. 8 GB SGA, whatever, or PGA, whatever allocated for my database instance memory, that 8 GB is not enough. And then as a DBA now, I need to increase it to another 8 GB to support that 100 user connection. So if in order to do that, another 8 GB instance memory increase, it's not possible at all because you have 8 GB 8 GB, 8 GB. 24 GB is utilized out of this 30 GB. You have left with only 4 GB or 6 GB. 24 GB is gone and 6 GB is left out. And then I cannot increase 8 GB. So I can engage Linux admin boss. My database is growing. A lot of users are connecting. I need to increase my SGA another 8 GB. I don't have enough free space on this server. And Linux admin is going to add another 10 GB memory. Now it becomes 40 GB. So 8 GB plus 8 GB, 8 GB, 24 GB is utilized. And you have another remaining uh, another 14 GB is free, 26 GB is utilized, 24 GB is utilized, and another 16 GB is free. Now you can go ahead and then increase your instance memory to another 8 GB. So that's where your both the Linux admin and DBA job will come into picture. If you're running short of a memory on server side, your Linux admin has to increase the memory. If you're running short of a memory at your instance side, since many users are connecting to your database, then it's a DBA who we need to increase the memory at database side based upon the available memory on the your server side. That's one part, the storage part, what we managing it. And again, another user comes, another user inserting more data. You need another 50 more GB of space. You have only 100 GB storage here, and then your server will crash if the end users are adding more and more data, and your server does not have enough storage. So in that case, we need to again ask Linux admin boss, whatever the 100 GB storage you allocated for this lab one, it's completely utilized. Now I don't have any free space left. Can you add another 100 GB storage? So I'm going to add another 100 GB storage here, and my database is continue to run. Another 50 GB storage will be consumed by this user too. So here both when it comes to database as a DBA, we are going to manage from the DBA side instance and the database. Instance is your logical structure, which is a combination of memory and background process, and database is your physical structure, where end user data will be stored under that. As and when the end users are keep on increasing, we're going to increase the memory of that instance. As and when end users are keep inserting more data and your database is getting increased, and then based upon your OS storage, will be keep on asking Linux admin to keep increasing the storage because we are adding more and more data into my database. I hope that's clear how this instance and the database architecture works for my database. Right? If I can quickly get my lab here, I can, whatever I explained so far, instance and database, I can quickly demonstrate here. I have this lab one. In this lab one, where is my this one? Okay. This is my lab one. In this lab one, I created instance. My instance name I given it as a DevDB.
Malik, I have a small doubt regarding this server side memory added. For example, see, the Linux team will be taking over all the memory added, all those things. But the people are asking any suggestions. Shall I provide the suggestions, or they maybe itself they will add the memory there?
That is your wish. Like, you have to understand whether you need a more memory because more users are connecting. Then you need to inform Linux admin boss. I'm increasing my database memory and I don't have memory on the OS side. You have to increase it. Until he don't increase it, whatever memory you're going to increase your database will crash because database does not have enough memory to take it from storage. Whatever the memory you're going to allocate to your database instance, all the memory has to come from your OS memory or the server memory. So first you need to check your server side memory is there or not. If it is there, then go ahead and increase in your database instance side. If not there, then no need to increase it. If you increase it, your database will crash or your server will crash.
No,
Right.
if they no Malik, if they people are approached to me as per our server side, we will find out and we will give the suggestions to them. If they people are not connected with us, they own itself they will add. On the time, how we will be check in this scenario?
Let them add it. If they want to proactively add them, let them add it. Like, we're going to run my Linux command. Free-g will tell you, okay, my 11 GB total memory, 1 GB is used, remaining 10 GB is free. I need to look at only this total memory. How much is total memory on this server? 11 GB. How much is used for now? Only 1 GB is used. So if it is totally 11 GB is consumed, your Linux admin maybe proactively add a memory. Let them increase it. So later I can increase it my database side. Either you can proactively reach out, or if they have proactive mechanism to proactively measure that server memory utilization. Never ever Linux admin will proactively add the memory by his own. First he will reach out to what all the applications are running on that server. And then if it's the application server, if it's a database server, he's going to reach out to respective team. It's the database server, he'll reach out to DBAs. This server is always running out of memory. What is the problem? Do we need more memory? If it's application server, you'll reach out to application team. This server is always running out of memory. What do we need extra memory on this one? If he's proactively reaching it out, that's well and good. Otherwise, we DBA, we have all our monitoring script and monitoring tools. We proactively reach out to Linux admin, boss, I need more memory. Right? Anyway is fine. Either he's increase it or we request and he's increase it. Anyway is good for us. Right.
Okay. Thanks, Malik. Thanks.
In this case here, lab one, I have instance I created with the name I given DevDB. At the time of your database creation, you are going to define this. Whatever the instance name, whatever the database name, you are going to define it. And even after creation of database, you can change it anytime. So while creation of this database, I given a name as a DevDB for my instance and database name as a DevDB. 99%, if it's a standalone, it'll always instance name and database are remain same. If I go here now on the server, ps-ef grep devdb. So what I defined here, my instance is logical structure made up of memory and background process. This memory is made up of SGA and PGA. And then background process is made up of mandatory and non-mandatory background process. If I do what are the mandatory and non-mandatory background process, I can do this process list. PS is the Linux command, PS process list, devdb, and I can see a lot of process running for my database here. So what I can do now, out of this so many background process here, what I defined here, my mandatory background process, SMON, PMON, checkpoint, log writer, and DB writer. These are mandatory background process. And whatever you're seeing here, PMON, mandatory background process, and your DB writer, log writer, checkpoint, SMON. So 1, 2, 3, 4, 5. These 5 are your mandatory background process. And if this process got killed, your instance will crash. So remember this one. You have this instance, and this instance is made up of HGA and PGA. And then this instance is made up of many background process. Let's take this is your mandatory background process, and let's take this as non-mandatory background process. Like there are so many. I'm just giving rough example here. Followed by this is your entire your instance architecture, and then at the back end here will be your database. So I give an instance name as a DevDB, and database name also DevDB. So whatever this background process you are seeing, mandatory background process here, PMON, and followed by you have here DB writer, you have this log writer, you have this checkpointer, and you have your SMON. These all are your 5 mandatory background process. Remaining all whatever you're seeing here, PSP, VKTM, Gen, MN, DBRM, and SMCO, RICO, all of them are non-mandatory. What I just listed out here. I just listed out few of them. Archiver, M1, MNLL, RICO, etc. all non-mandatory background process. So anyone want to connect to, okay, these are background process. And coming back to a memory, so I'll connect to my database, and I can do show parameter SGA underscore target. I'm just giving only one component. There are so many subcomponents inside that, but I want to check only SGA underscore target, which is of 3 GB. Where is that diagram? Okay, here. Let's remove this one. Don't need. Remove this one. Remove this one. Okay, now let's say show parameter PG underscore. I'll just go with the PGA. PGA underscore aggregate, PGA underscore aggregate limit, and PGA target. Sorry, my bad. Show parameter PGA. So we have PG aggregate limit, PG aggregate target. Don't worry about that for now. Let's say your PG aggregate limit, which is up 2 GB. 2 GB plus 3 GB. Totally 5 GB memory is allocated for this DevDB. Okay, DevDB as we talked, which has a memory, and for this one, SGA is 3 GB and PGA is 2 GB. 5 GB memory is allocated for my instance memory. And this background process, some of them are mandatory and some of them are non-mandatory. So now at the back end, this instance is attached to a database called DevDB. Both the DevDB instance and DevDB database name are same here. So if I go to that database, I can do select name from $, data file. So under this location, user on app, Oracle, Wara data, DevDB. If I go to this one, data file. So whatever you are seeing, temp, user, syssoc, system, undo, these are the default data file will be get created. So 1 GB, 1.5 GB, 130 MB, 500 MB, altogether it become roughly around 3 GB. 3 GB is your total database size. And as and when end users are connecting and adding more data, your database will keep increasing. As and when the end users are keep more and more end users are connecting to my database instance, this memory is getting used. 3 GB and 2 GB all getting used, and then your database will not function fine. So as a quick example here, if I do ps-ef grep devdb and then wc-l, 61 is your total count. So if I take one duplicate session, I'll take one more session for the same server. So my server IP is this one. Right. So now let's run the same command ps-ef grep devdb, and then how many processes are running for the devdb? 61 processes are running for that devdb database. The background process, whatever we are seeing here, ps-ef grep devdb, all of them here, whatever you are seeing. So now any users connect here, I'm gonna connect SQL plus /s sysdba. One users are connected. I'm connecting locally. The user might be connecting via application. And if you go back to this other session and you can count here, now it becomes a 62. One extra process connected. And if this user, whatever he connected here, if he do a lot of transactions and another 100 more users are connecting to my database, and then these processes are getting increased my server side. And then the memory will be keep consuming by those processes as and when that user do a transactions. And if I exit from my database, and then if you see my process will come down, it becomes 61 again. So 1000 user connect, 1000 process will start on my database server side, and all of them will start start utilizing the memory. And then enter this 3 GB, 2 GB memory is consumed. My server database goes out of memory. And then I need to, as my DBA job, to increase this SG and PJ size so that it will handle those 1000 users. Fair enough. That's a quick update on how your database architecture you can map it with your actual end user point of view. At what time you're going to, at what point you're going to increase the memory, at what point you're going to increase the storage. And right now, if I look at this storage, this is my database storage where my database resides. Your database may be residing under OS file system, as I mentioned here, or NFS, SAN, NAS. Right now, it's a OS file system. File system type here. Okay. Now, if I check this, what is this file system utilization now? df-h. Df is a Linux command again. You run this df-h and utilization of this file system. So my storage admin has given 79 GB storage, and then out of that 48 GB is used. Another 32 GB is free. So whatever my data file here, temp user system sysocks, they will be keep growing. Up to another 32 GB free space is available on this storage, and my data files will be keep growing. When this 32 GB free space is utilized, now I need to ask my Linux admin boss, entire 79 GB what you given, it's all consumed. Can you increase the storage? He's going to increase the storage. Then my database is continue to write the data. My end user transactions are continue to run fine without any issue. Right. That's about your overview or the high level look how you can measure it. But now let's go to that real definition of your database architecture. If I take one example here, okay, let's take this one. Whatever we talked so far, you have instance and you have this background process. This combined together, it make you total instance. Sorry, not instance. You have this SGA memory. Let's remove this memory, not needed. Okay. You have this SGA, you have this PGA. Combining these two together will make your memory, and then you have this background process. In that background process, we have this whatever the background process. I think there's a typo, meaning the syntax or the format is not clear here, but let's bear with that one. This background process, here it's a mandatory background process, and here I given few example for non-mandatory background process. Combining these two become your background process. At the back end, you have database data files, and there are so many other files, but for now it's enough. So any user connect to my database. Again, there's a different concept of listener will come into picture and all, but for now, don't worry. My database, any user connected to my database, like PJ will be allocated for him, and then another client will connecting to my database, another PJ will be allocated for him, another user client connected to my database instance, another PJ will be connected for him. That's why PGA is called as a program global area or private global area. If there's a three users are connected, three PJ memory will be allocated for them. If the 100 users are connected, 100 PJ memory will be allocated for them. PGA stands for your, where is that one? Right. PGA stands for your program global area or private global area. So each user has its own PGA. So SGA stands for system global area or shared global area. So whatever those end users are connected, all of them are using single SGA. Let's say in this example, what I'm giving, the client one, client two, client three. One, two, three. Three clients are connected. They have their own PGA. And then, but all of them are using one single SGA, system global area or shared global area. Right. And then inside that SGA, you have so many sub-memory component. Whatever the transaction they do, let's say this guy is doing insert, this guy is doing update, this guy is doing delete, this guy is doing create table, this guy is doing drop table or modify table. Whatever they do, create, insert, update, delete, drop, truncate, whatever the transaction they do, all those transactions will be happen through your SGA. From that, based upon if this guy is doing insert, the record will go from your SGA to data files. If this guy is doing insert or if this guy is doing a select, the data will come from the data files to memory and then given it back to that end user. Right. So that is your high level overview how your end user transactions will be visualized with the help of this SGA and PGA. Again, if you go inside each of those SGA and PGA, there are so many subcomponents, and based upon the transactions, those different SGA component will be used. I will cover that in a minute, but meantime, let's take few questions in the chat here. Could you please zoom in the screen? Okay, I think I already done that one, right? How much is a PGA can be resized? If I have a Again, there's a different story for that. How much your PGA you can increase and all. I'll just cover it here in a minute. Let's drop it here. All right. So we inside my database. So if I go here, I have two parameters here. Question is how much max PGA I can allocate. So we have two parameter here. Let's say I have a PGA aggregate limit set to 2 GB, PGA aggregate target set to 1 GB. Right now, your database will default assign 1 GB PGA for your end users. If that end user is using more and more memory, this 1 GB PGA automatically get increased up to 2 GB. When that end user hit this 2 GB max memory, then no more further PGA allocated. This is a max. the user cannot use more than this max PGA. Same thing for the SGA. Show parameter SGA. So in that we have SGA target. How much max? Like, this is how much max PGA can be allocated to a user, because the PGA is a user specific. How much max SGA can be allocated to my database, because SGA is my database wide, because all the users are connecting and using the same SGA. So that you can take a look here. So you have again SGA, my bad, SGA target here, and then SGA max size. My SGA is here default 3 GB allocated. All the users who are connected, those all users will be consuming this 3 GB memory within that 3 GB memory. Let's say if you have set this SGA max size, let's say 1000 or 10,000 M, meaning that's a 10 GB roughly. So initially your SGA will be assigned with the 3 GB. All the users are connected, they will be using entire this 3 GB. Let's say user 1 maybe 1 GB, user 2 maybe 100 MB, user 3 maybe 200 MB, user 3 maybe 500 MB. All the connected users, all summed together, it cannot go more than 3 GB. Once this 3 GB is crossed, then your your SGA cannot be increased automatically. Here in PGA, initially for one user, it will be 1 GB allocated. As and when that user do more and more transactions, automatically this PGA will be increased, and up to 2 GB it got increased automatically for each user. But here in this case, all those hundreds users who are connected to my database, all summed together, they cannot use more than 3 GB. Once they hit this more than 3 GB, then server will perform very, very low and server performance will degrade. And as a DBA, now I need to increase this PGA target to 5 GB. Then all the connected users can use maximum 5 GB together. And again, if it hit 5 GB max memory, then as a DBA, again, I can increase it to 8 GB. Then all those 100 users who are connected, they will be keep doing the transactions, and again they hit that 8 GB max memory. Then I can go and then increase it to 10 GB. That will meet this max 10 GB. For that, I don't have any option to increase it. I need to increase this max size to 20 GB. Then gradually I need to keep increasing this SGA target. And one thing to understand here, your PG aggregate limit is a max hard limit. Your SGA max size is a hard limit. You cannot increase more than that. And your SGA target is a soft limit. When they hit this soft limit, manually you have to increase it. Your PG aggregate target is a soft limit. When the user hit that limit, it automatically resize. You don't need to do this. But in under the hood, any of this memory hit the hard limit, max size here, aggregate limit here, is a DBA job. We have to increase those memory manually. And in order to increase them, you need to first check whether you have a Linux server side free memory or not. Right, that's a answer for this question here. Lalit has asked, and there's a few more questions. What happens when the user commit the transaction? I have not talked about the transactions. We'll talk in a minute. What is the instance recovery? What does Oracle performs? We'll talk about that in a minute. Okay. All right. I think we have done those questions. Okay. How much RAM max can allocate? It's all depend upon your server. You can go with as long as whatever the supported one. RHL, Linux level, if there's any limitations, your Linux admin will be aware of that. How much max RAM and CPU can be allocated for server. But as a DBA, as long as the server has enough memory, CPU, RAM, hard disk, I can go and then utilize it for my database. All right. Now, quickly define all of this. Okay, this may be uh, your interview questions. So we talked about here all this database architecture, what is instance, what is database, And we talked about that again. Instance is logical structure made up of memory and background process. In the memory, HGA and PGA, and HGA is your system global area or shared global area, and PGA is your program global area or private global area. Inside HGA, you have buffer cache, log buffer cache, shared pool, large pool, Java pool, stream pool. And inside PGA, stack space, bitmap, bit area, sort area, cursor area, UGA, temp area, and mandatory background process, non-mandatory background process, and then all your data files. So we'll go with the one live example now. Let's go with this one. Before that, let's keep a one-liner definition. Okay, now for Oracle architecture, I said instance and database. Um, I'll just give a definition for this one. SGA, system or shared global area. And then PGA, I talked about private or program global area. Now, out of this different memory segment, so these three are very lightly used. Large pool, your IO activity, especially for your backup. And then your stream pool, your Java pool, if your application uses your JVM framework, then Java pool will be used. Otherwise, Java pool will not be used. Stream pool, whenever you're using a golden gate or table replication, then your stream pool will be used. Otherwise, your stream pool will not be used inside your database. These are all fair enough, very lightly used in my database instance. But these three, your database buffer cache, log buffer cache, shared pool, are very largely extensively used inside your database. Meaning, let's take this example here. I have this shared pool, database buffer cache, and then log buffer cache. Remaining all whatever I talked, large pool, your Java pool, stream pool are very lightly used. They will never use for end user transaction. But for the any end user transaction, these three are the memory component very extensively used. Meaning, let's say these are the three main memory components inside my SGA. And then let's say my user one connected to my database, you will be allocated with this PGA. And then one process will be started for him, server process. We talked about that one right here. Where was that? The moment I connected here SQL plus SHDBA, my process 61 becomes 62. One extra process will come into picture. That's a process here. You can call it as a server process. And the second user connected to my database instance, another process will be started, server process. And then memory will be allocated for MPGA. If this same thing, third user connected to my database, another server process will be started for him, another PGA will be allocated for him. My fourth user connected to my database instance, another server process, another PGA will be allocated for him. And then all this background process, pmon, dbrater, logrator, smon, and checkpoint. These are mandatory background process and remaining all are non-mandatory background process for my database instance. The moment I say mandatory, you might assume, right? Mandatory. It has to be up and running. If somebody kill this process, my instance will crash. Other than this mandatory background process, whatever non-mandatory, if you kill it, it will be automatically restarted by my database instance. You don't need to worry. But for this mandatory one, if anyone kill this process at OS, your instance will crash. So underlining, you have this database here. You have your data files here. Whatever those data files we talked about, that system, sysocs, undo, user, temp. Where is that one? Right here. Data files, system, sysocs, user, temp, undo, all those data files, whatever we're seeing here. And then we do have something called redo logs. We'll talk about that in a minute. Let's assume this particular data file, what I'm talking about, this user data file, which will hold your end user data. That user data file has this employee table. That employee table has this employee ID, employee name, salary. Employee ID 1, employee name is A, salary is 1000, employee name ID 2, employee name is B, and 2000 is salary. The client 1 connected to my database, he's doing select star from employee, meaning he want to read this employee ID 1 and employee ID 2. He's doing select star from employee. The moment he run this select star from employee, Oracle internally something we have optimizer, which will parse this query and then which will generate the SQL ID for this one. Select star from employee will be internally converted as a something called SQL ID 1A, 1A, 1A. Oracle is going to generate that internally SQL IDs. And that SQL ID will be kept under your shared pool inside library cache. So remember here what we talked right here. You have something called shared pool. Inside that shared pool, which is part of SGA, which has a library cache and data dictionary cache. So whatever that SQL ID is nothing but it's a representation of your SQL statement, whatever the end users runs. That SQL ID will be kept under this library cache, and whatever the employee table structure metadata will be kept under this data dictionary cache. Fine. Once that is done, the SQL ID is generated, and then your optimizer further goes to your database buffer cache for execution. Here, whatever happens on the shared pool is called parsing. What is parsing? Meaning converting that SQL statement into SQL ID and then keeping that into your shared pool. That's called hard parsing. Why it's a hard parsing? Because that SQL ID was not exist in the shared pool. This SQL statement is executing for the first time. Then it has to go for parsing, meaning whether this syntax is correct, whether there is a typo, whether this employee table exists or not, whether that user has access or not, all will be checked. That's your parsing. Syntax check, semantic check, and your permission check. And then once the parsing is done, it will generate this SQL ID and then kept it under this library cache. Once the parsing is done, then it will go for your buffer cache for your execution. That query is going to execute now in the buffer cache. What exactly that execution? In that execution, whether that employee table is available in the buffer cache or not. This is the empty buffer cache, nothing is there. Then further, this all will be done by your server process. Whatever the query executed by this end user is taken by the server process. Server process is executing all these end user transactions. And server process did not find any data in this buffer cache, and the server process will go to my data files, that user.dbf or whatever the data file. In that data file, you'll get this employee table and then get that employee table back to buffer cache and then put it on that memory, buffer cache memory. And then that result will be given to that end user. Select star from employee, and this employee will get the record 1 and 2. This is your very first time the query will how executes. Now look at this second user here. He's running the same query, select star from employee. And that server process will take that query. And this time this query for the second user will not go for parsing. This query will directly, server process will directly go to a server process here, server pool. In that library cache, will check for that select statement. Okay, this query is already executed in the past by somebody. I'll just simply take that SQL ID and then I'll go for execution. Once it go for execution, and then the second user again will be one more lucky for him. One more, like you can say, very, very fast execution. He is so lucky that whatever the result he needed, that result is already available in the buffer cache. And then the server process will not go to data file, fetch the data again, because already data is there. The server process directly read this data and then give it to that end user. So here two things happened. One is for the user one, if I put down here in this notepad, client one, parsing happened. Parsing meaning the query is executed for the first time, that SQL ID is not available, and then it went for a syntax check, semantic check, permission check, and all. Let's say that parsing took 2 minutes. And then the query went for execution. Execution happened on this buffer cache. Where is that one? Okay, execution is checked in this buffer cache. That employee table is not there in the buffer cache. And then that query went to my data files, which is under OA storage or the ASM storage. From there, the data is fetched and then returned to buffer cache and then sent to end user. That is your, we call it as a cache miss. Cache miss meaning in this buffer cache, the data was not there. It has to go to data file and fetch the data. And let's say this took 2 more minutes. And total time for this query execution took 4 minutes. Let's take off your client 2. Client 2, sorry, we'll take it as fetching the result. Let's say 1 minute. Right, so parsing took 2 minutes. Execution, that cache was missed. It has to go to data file, fetch the result, write it back to data files, another 2 minutes, and then fetching that result and giving it to that end user. Fetch the result and give it to end user. That's the client one within 1 minute. So total it took 5 minutes for this entire query execution. For this client 2, parsing did not happen because already query executed. We call them as a soft parsing. So here parsing happened, we call it as a hard parsing. Hard parsing meaning where for the first time the query is executed, which has to go for all the syntax check, semantic check, and execution, a permission check, and then go for execution. So it is a soft parsing, meaning the query is already executed. I have that SQL ID. I'll just make use of that. So let's say I'll roughly hypothetically I'm giving here. It's not going to spend hardly few milliseconds, but I'll just put it at 0 seconds, 0 minutes, and then it went for execution. Luckily, that end user, second user 2, client 2, as lucky enough, the data is already available in the buffer cache. Give me 1 second, guys. All right, sorry for that, guys. Okay. So in this second one, this is a cache hit. We call it as a cache hit. So again, cache hit meaning already data is available in the buffer cache. No need to get it from the data file and then give it to end user. So again, I can say it's a 0 minute. Data is already available in the buffer cache. It's a cache hit. Then totally it's gonna go for fetching that data from the buffer cache and giving it to that end user. Fetching the results and give it to that end user. That will be 1 minute. Only this reading the data from buffer cache and send it to end user. So here total time taken for this one is 1 minute. So always you can say that for the first time client who run that query will be always take more time because of all the cache miss, hard parsing, and then fetching the result. For the second time, it's all like soft parsing, cache hit, and then get the result from directly in the buffer cache. So here only the time spent is for fetching the result from the buffer cache, give to end user. Makes sense how this three memory component here, your shared pool, database buffer cache, library cache, which will play very, very important. Library cache, I not talked on that. We'll talk in a minute. So that is for your select query, and then for the first time select query for the second time. And if let's say somebody doing an insert or somebody doing update, let's take those two example here. Same thing, server process, PGA, and then doing this on server process, PGA. He doing insert employee ID 3. And again, the moment you do insert employee ID 3, same thing. It always go for parsing. It will generate the SQL ID. Let's say 1B, 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 1B. New SQL ID generated, kept it in the library cache. Employee table is already fetched here in the data dictionary cache. Then go for further execution. What it says here, insert into employee ID 3. Right? You're going to insert that, like here it's a employee ID 1
Malik,
and 2.
sorry for my disturbance to you, Malik, regarding this cache miss and cache hit. For example, see, user is execute the select command and retrieve the data to data file and kept it in buffer cache. Okay, fine. But second user also retrieve the data, but data is retrieve the data. But already you are saying that is a cache hit, but data
Right.
is not available in this database, this data files. How will they, if you require the data, means where you can.
Data is not in the buffer cache.
No, data is data. First user kept it the data
He
in
kept it data user ID 1 and
buffer
2.
cache,
Yes.
first user. But second user is not retrieve the data, second same user, same query, but he is not available the data in this database storage.
If it is not there, then you're going to go to data file and fetch the data. Cache miss again.
Second user also.
Right. If it is not there. Already
But
data is 1 and 2 is there here. User ID, employee ID 1 and 2 already kept here. Second
okay.
user will do that one. You always get the data from the buffer cache. If by default your data is erased from this buffer cache, the second user also will go to data file and get the data. Default Oracle will always serve the data from the buffer cache if it is there. If it is not there, then only go to your data file and fetch the data.
But how much of the time take it will for the user and user two regarding this situation? Both user come, user one also come and fits the data, and user two also data file and fits the data. But how much of the time it will take? But user one it will take the time, more time, but user two it will take the more time.
We cannot predict it. Who are going to do that one? The first user, it all happens in micro millisecond. If the one user do first execution, second user will get the data. If the second user will do a first execution, the second user will get the first data. It happens in million
yes,
microsecond. You
yes,
cannot predict that.
yes, correct, Marik. One thing, see, already see user and fits the data from data file already buffer cache, buffer the data is stored in buffer cache. Okay, fine.
Right.
But why should I user two will come and retrieve the data in
No, it never.
data file?
I already told, right? Any user has done the execution, data is already there in the buffer cache. Rest all user will directly use the data from the buffer cache. In case if your data is missing from the buffer cache, then only you're going to go into your data files.
But
It's not permanently. This data
yes.
is not permanently set here.
No, Malik, already see one thing. Node one is the user one is connected node one, user two is connected to node two. Okay, fine. But
No, we're not talking about RAC here. Node 1, node 2. What is that node 1, node 2? What are you talking about node 1 and
no,
node 2?
no, I'm not talking. Oh, okay, fine. See, if whenever the user two is required the data, he will fit the data in data file, then it will stored in the buffer cache. That is no Malik here we are saying.
Right. User 1 executed the query. He fetched the data from the data file. He kept it under buffer cache and then data is sent to user 1. User 2 comes now. He will never look for the data files. He will first check for the data in the buffer cache. If it's there, directly sent to that user 2. If it is not there, let's say your buffer cache is erased. Whatever this data user 1 has put here, user ID 1 and 2, but this data got erased. And then this user 2 will go here and then again he has to get the data from the data file and then put it over here back or put it over here. Very first priority is to always check for your buffer cache if the data is there or not. If it is not there, then only go to your data file. Otherwise, it's not gonna go to data file directly.
Okay. Both user like that retrieve the data from data files. No, Malik here.
Right.
Okay. Thank you, Malik. Thank you. I understand that one.
Right. So now let's take this third example, what I'm talking about. Inserting. This guy is doing an insert. Insert your data employee ID 3. Again, 1B, 1B, 1B. The employee ID, the SQL ID will be generated and go for execution. And then this employee ID 3 will be written here. This will be your employee ID 3. And then the moment these transactions are done here, and then we'll give back to that user, okay, your data is saved. And then this fourth user is doing insert employee ID 4. He's doing employee ID 4. And then again, this time, you're going to make use of the same execution plan here. 1B, 1B, whatever this employee ID insert 3, same thing here, employee ID insert 4. You're going to make use of this already executed query and go for execution. And go for execution, this employee ID 4 will be written here. Both of them are insert query. For the select query, your log buffer cache will never be used because you're just reading the data. Here you're doing insert data. This select insert into employee ID 3, the transactions will be written here. And then insert into employee ID 4, transactions will be written into here, this buffer cache. And then this user 3 is going to do commit. Commit meaning whatever I did insert employee ID 3, save that data. Whatever this user 4, he's doing an insert employee ID 4, he has not done the commit. He has not done the commit here. Meaning this data is not guaranteed. Whatever this user 3 had done the insert employee 3, he did a commit, meaning this data is saved. We saved the data here on the buffer cache, and then we told this user, your data is saved. And then this user has did the insert employee 4, but he has not done the commit. His data is not guaranteed. So in that case, what happens? Let's say your database has crashed. Your instance has crashed. Your server got rebooted. This is all about whatever we're talking about instance. This is all we're talking about your SGA, memory, RAM. Whatever the memory in the RAM is a volatile, which is not guaranteed. So when you next time as a DBA, I'll log into that server one and I'll start my database. Let's say I'll just give you a quick demo here. PS-EF grep devdb. So I'm just gonna kill this one, pmon process, or kill this smon process, or whatever the mandatory background process. So I'll go with this smon. I'm gonna kill this one. Kill -9. I'll go with this pmon process or smon process. But I'm gonna kill this one. Kill -10. Sorry. The moment you kill this one of the mandatory background process, smon, pmon, debrider, logreader, checkpointer, your entire instance will crash. If I do ps-ef grep devdb, not yet countdown, give a few more minutes, devdb. Go back. So now connected to idle instance. Let's wait for a few more minutes. DevDB now gone. What happened here? So earlier there are so many background process for my DevDB database. Now there are no more background process because we did a kill one of the mandatory background process. Where is that one? And we killed that one of the smon background process. It took few seconds and it went down now. Now you try to connect your database instance. It says connected to idle instance, meaning nothing is running, idle. So earlier when I tried to connect here SQL plus SHDBA, it used to tell that connected to your 19C and connected to your 19C Enterprise Edition production and you will be into this SQL command prompt. Now this time it's saying connected to idle instance, meaning idle instance is down. Fair enough. Now what happened here, what I was explaining, this user, they have done these transactions. Where was that? Okay, now this user 3 has done the insert, user 4 has done the insert, user 3 has done the commit, user 4 has not done the commit. But all the data is stored under memory. When your database crash happened, now I'm doing this database startup. So if I go back here, I'm going to do as a DBA, I'm going to do start my database instance here. There's that one. The moment I start it, then there's something called recovery will happens. What is that recovery? Whatever this user 3 and user 4 that done the transaction, that transactions will be logged into this log buffer cache, right? And this moment user do a commit, whatever this transaction, your log writer, one of the mandatory background process, log writer will take those transaction information right into your redo log. These are the physical logs in your server. When your server was crashed and when you are now starting up, you did a here startup. When you do a startup, your SMON background process, SMON, LGW stands for log writer background process will take that transaction information from the log buffer cache, write those into redo log files, online redo log files. Whenever there's a instance crash happens or shutdown happens, or the abnormal shutdown or server crash happens, when you start your database instance next time using the startup, there's a one more background process called system monitor will come into picture. The system monitor will read this redo log. This redo log has the two entries. This is for user ID 3, this is for user 4. This one is a committed transaction and this one is a non-committed transaction, uncommitted transaction. Because here this user 4 has done the insert, but he has not done the commit. That data is not guaranteed. This user 3 has done the insert, but he did the commit. That is a committed, guaranteed transaction. This SMON process will read this redo log and then it understand, okay, there are two transactions, insert into employee ID 3, insert into employee ID 4, and one is committed and one is uncommitted. So this committed transaction, your SMON will go for roll forward. Roll forward meaning re-execute the transaction. Re-execute the transaction meaning rerun that query and then it's going to insert the data employee 3, employee name is C, employee salary is 3000. And then that data will be stored under this data file. And whatever this uncommitted transaction, roll back that one. Means discard that transaction. And then your database will get opened here. After that roll forward and roll back is done, your database will get opened here. And then when somebody go and then check that employee table now, that employee table will be having a record 3, 1, 2, 3. Then after this next startup here, whatever we did a startup here, after you do a startup, whatever this SQL IDs are gone, whatever this data in the buffer cache is gone, whatever this in the log buffer cache is gone, all this data will be erased because this is a SGA, this is your RAM. RAM meaning volatile memory, your server memory. Whenever you bounce your database instance or shut down and start up, or whenever server reboots, whatever the details in your memory, SGA and PGA will be, everything will be erased. It will be a brand new database now. Right, so now again user 5 comes, he do the select star from employee table, again going to do brand new execution because everything is erased. So that's why production database getting a downtime is very, very challenging one because you're gonna erase everything from your memory. Ideally, you're not gonna lose any data, but whatever that query execution plans and whatever data from the buffer cache, everything will be getting erased. Will be starting as a fresh database. All the queries will start from the fresh. So make sure that when you're doing a downtime, all this has to be considered. And especially when you do a shutdown database, there should not be any uncommitted transaction or there should not be any crash in your database. Because whenever there's a crash, your database will be inconsistent, meaning your data files, whatever data is not matching with whatever the committed data. And when you start your database for the next time, your SMON will come into picture for those any transactions which are committed or not committed. And according to that, your S1 will go for roll forward and roll back and bring your database into consistent state. Right? Those are your two background process, S1 and log writer. S1 is for your system recovery whenever crash happened. Go for roll forward and roll back based upon the committed or uncommitted transactions. And then log writer is to write the data from the log buffer cache to your redo log files. There are two more background process which are mandatory. A PMON. What is this PMON background process will do? PMON stands for process monitor, meaning whatever this connected user, client 1, 2, 3, 4, all those connected transactions, connected users, just keep monitoring those transactions. If any users are disconnected due to some network issue, this connection has some network issue, this user is disconnected. Or this client 4 is doing some transaction, they have some network issue, this connections are transaction disconnected. Or this user 2 has connected and he's not doing any transactions, he's just sitting idle. And then there's an idle timeout inside my database. Any users are sitting idle for 1 hour, disconnect that transaction, disconnect that user session. So this PMON process will keep monitoring that end user transactions or end user sessions. If any users are session idle, timeout happened, or any users are network disconnect happened, we're gonna clean up those user sessions. That's the job of PMON process. And then we have this DB writer, DBWR. What the DB writer will do? Let's say all this user 1, 2, 3, 4, they're doing the transactions, they're putting a data into this buffer cache. Whenever this buffer cache is full, there's a condition 1/3 full and all. Let's take it as simple definition. Whenever this buffer cache is full, your DB writer will take all those modified data or the new data from this buffer cache, write everything into your data files. When this entire buffer cache is full, let's say client 10 is coming, he's doing the same transaction, some transaction, and then there's no more space in the buffer cache. And then whatever the old written data here, old excess data, your internal mechanism will going to erase this data, old data, and then write that whatever the new data. This all the buffer cache, all this SP, library cache and data directional cache, all this log buffer cache, the data will be, the storage or the memory will be reused again and again. Whatever the old data will be erased and the new data will be written. Based upon when this is full, like your buffer cache is full, your DB writer will write everything into your data files, and whenever the new transactions happened, you're going to check out which is the old written data and then erase that one, write a new data. So that's a continuous process. Same thing goes for your shared pool also. Whatever this library cache will be keep appending that SQL IDs, and then that buffer, your library cache is full. Whatever the old written or old accessed SQL ID will be erased and the new SQL ID will be written over there. Right, and then same thing happens for your update statement. If you do the update statement, same thing. Your server pool, database buffer cache, library cache, and then committed, uncommitted transactions. Everything will be comes into picture. When you do update, when you do create, when you do modify, or all those transactions. So those are your underlining.
Malik, sorry for my disturbance to you. See, Malik, just now we had a discussion, right? In the buffer cache, old data will be erased, new data will be raised, right? So, for example, say new data, old data, how it will be erased? Maybe is there any processes available or manually?
Not process, you're going to maintain something called LRU. So internally, Oracle will maintain LRU, least recently used. So we're gonna keep a priority. Okay, this data block here used 1 day back, and these blocks are used just 1 hour back. So we're gonna put a pointers how many times this block is accessed, how many times this block is read, and based upon that, your LRU algorithm will keep a priority. So whatever the high priority will be, data will be preserved. Whatever the least priority, least recently used, will be kept. Will be raised from your buffer cache. So that's the internal mechanism how Oracle will maintain using this LRU algorithm.
Yeah, least recently used. Okay. Yeah. Okay. Thank you, Malik. Thank you.
All right. So I'll take a pause here for any questions so far on this. How queries will work, how your database architecture you can utilize here. There's a few questions in that. Can we manually cache the SQL query? Yes, you can do that one. You can connect your database and you can catch that whatever the SQL ID you want it. Right. So now I'm going to talk about a little bit. Okay, what I'm going to talk about now. Let's go here. Okay, this one. So far, what we understand about is the logical structure. Right? Let's say your database architecture. Okay, close this one. Give me a second. Close this one. Okay. Database architecture. We talked about instance, and then we talked about database. We have not yet talked. So we talked about this instance. Instance is memory, SG and PGA, and then BG process. For this database, we talked about data files. All the end user data will be stored here. For the DBA, I can go to that location. So I'm already on that location. I can physically see those data files with whatever the size it has. But when it comes to database will visualize in different format, logical and physical. Physical is just a data files. Whatever I'm seeing here, that data file may be your SAN or NAS or NFS or ASM or RAW or file anywhere, whichever based upon where your database running, the data files will be resides over there. But your database will look into different angle. The single data file, which will be looked into a table space, segments, extents, and data blocks. So let's take this one in a I'm going to try to draw a diagram here. Let's say before that, let's put this one. This is your physical data files. Right. So you have this instance, and then this instance will be having your SGA and PGA, and then these will be having background process. This is all your instance, and this is your data files or DB, database or data files. So now if I create a user, like, let's say I have how many data files I mentioned here? Temp, user, undo, system, sysocs. All these data files are represented as respective table space. System data file, system table space. Sysoc data file, sysoc table space. Undo data files, undo data file and undo table space. And user data files and user table space. Right, whatever systoc table space, system table space, undo table space, user table space, temp table space. All the data files are mapped to table space. That's your logical structure my database will think of. So entire this instance and database, we call it as a instance and data files, we call it as a database architecture. So whatever this database will be visualized as an instance and data files. And these data files, my Oracle will think it's a logical format called table space. That table space is made up of segments, and that segment is made up of extent. That extent is made up of data blocks. Let's see if I connect to my database and I create any user. Connect back to my database, create user, let's say apps, identified by apps. So I created this user called apps. At the moment you create a user, that's the application user. So this apps user is assigned with table space called users. So what we talked here, these data files, we have system data files, we have sysac data files, we have undo data files, we have temp data files, we have user data files. User data file is the one end user data will be stored here. Temp data file is the one where temporary transactions will be saved here. Like select star from employee, ordered by employee ID, ascending, descending. Kind of a sorting operation you do, all those sorting will happen in this temp table space, temporary operations. Undo data file is for undo operations. See, whenever you do update employee table, update your employee ID 1 from salary 1000 to 2000. When you do a modify the data, old data will go to this undo data files. Because whenever you want to roll back, like you updated that employee ID 1, you change the salary from 1000 to 2000. 2000 will be updated on your data files. But that old 1000 will be stored under your undo data files. After a few minutes, like after 2-3 minutes or after 5 minutes or after 10 minutes, you want to roll back that okay, unnecessarily I updated for the employee ID 1 salary from 1000 to 2000. So now I want to roll back that. So where is that old value? Old value will be stored under this undo. And that's why somebody asked your snapshot is too old. Right? What is this snapshot is too old? In the chat, if you can see snapshot is too old error. Meaning we have something called undo retention. Undo retention is default 15 minutes. And then any data, old data is stored under this undo table phase will be guaranteed for 15 minutes. If you try to access data more than 15 minutes, old data, it may be or may not be available in this undo data file. That's where your undo snapshot is too old. Whenever you're trying to access old data more than 15 minutes, and then you may get sometimes snapshot is too old, especially for your export or especially you are doing a import or the export. That time, not for the import, for the export. You're trying to do this one. During the export, you can see this snapshot is too old, meaning you're trying to access the data which is older than 15 minutes because you set the undo retention is to 15 minutes. If the data is written more than 15 minutes back, then that is not guaranteed. You can end up with this error message called snapshot is too old. And then remaining two tables data files are system and sysdocs for internal your operations, your database operations. You're going to use this system and sysdocs for the storing metadata, base tables or dictionary views or dynamic performance views. But for now, what we're interested in is this this user data file.
Malik, sorry for my disturbance to you, Malik. See, just now we had a discussion with undo table space and the snapshot table snapshot, right? Example, see undo table space, how many days of the data it will be stored in undo table space?
Based upon your undo retention, if it is default is 15 minutes.
Okay.
If your data may be stored for 1 week, let's say you did an update statement like what I said, what I just told you, right? Update your employee ID, update employee table for employee ID 1, change that salary from 1000 to 2000. The moment you change it to 2000, that old value 1000 will go and then sit under this undo data files. After that, next 1 week, you have not done any transaction in your database. Then entire 1 week, your data will be in these undo data files. And next 1 month, you don't do any transaction in your database. And next 1 month, your old 1000 salary will be sit under this one. But what is guaranteed? You have something called undo retention equal to 15 minutes. Boss, 15 minutes, I can guarantee that your data will be resides under this undo data files. After that 15 minutes, I don't guarantee. It may or may not reside in this undo data files. If your database is too busy, heavily involved in a lot of transactions, whatever this old data is written here will be rearranged and return the new data if your database is too busy. If your database is not busy, idle, not doing anything, then whatever data you return will be retained forever until unless if there is no need of undo.
Okay.
Right? Based upon your undo retention, what is guaranteed that time, if your database is super busy, still it's going to maintain minimum 50 minutes of data in this undo data files. Okay. It's not going to erase within that 15 minutes.
Okay, I think, but what the final scenario answer is, undo table space maybe depend upon our retention policy data, it will be stored, or else maybe 15 minutes data it will be stored. That's it. No,
right. That's correct.
Okay.
So
Malik, Malik, the one more question. A snapshot means exact copy, no.
old copy.
Old copy. Okay. Thanks, Malik. Thanks. This is my
Right.
problem.
So whatever this user table, user database is, user data file is the one where the end user data will be stored. Remaining all system sysocks for internal database use. Undo data file is for old data. Temp is for your temporary sort operation. But user data file is the one where the end user data will be stored. And each of these data file has its own table space. But right now here, what I did, I created a user called apps. Default this apps user assigned with a table space called apps table space. Where was that? Right here. Whatever the users I created here, apps is the users I created. This apps user is default assigned with the user table space. And this user table space has user data files. And whatever this apps user is connect to my database and then do any transaction like create table, that table will be created under this in this user table space. Meaning underlining user data file will be holding that apps user data. And this apps user is going to insert 1 million record. All that 1 million record will come under this user table space. Underlining user.dbf data file will be filled with that 1 million record. So this is your logical representation how your database will think of each data files. Each data file, whatever you create, those data files will be mapped with the table space, and that table space will be mapped with the segments and extents and then data blocks. Whatever the user you're going to create, that user will be default assigned with the default table space called users. And whatever the end users are going to create table, all those tables and whatever the end user is going to insert data, all the table data will be stored under that particular user table space, meaning underlining whatever the data file assigned for that user data file, the user table space, the data will be stored under that particular data files. So if I quickly go here on my lab, select name from $, data file. So my database has system, sysocs, undo user data file. Select name from $, table space. I have sysocs table space, system table space, undo table space, user table space. All of them are mapped here. For this undo table space, you want to read the undo data files, you have to go for the temp file. Sorry, for this temp table space, you want to read the temp data file, you have to go for temp file. Select name from temp file. So we have this temp file. For that, this temp table space. We have this remaining system sysocs undo user, system sysocs undo user, respective table space. So along with this $, this is your dynamic performance views, and we also have a data dictionary views, DB underscore. So describe DB underscore data underscore files. So you can map it. What is the file name mapped with a table space name? Select, or you can do set pages, lines. Select my table space name, comma, what is the associated data file name from. So I have this system mapped with the system data file. I have sysocs table space mapped with the sysocs data files. I have user table space mapped with the user data files. I have undo table space mapped with the undo data file. Right? It's a mapping between your physical data files versus your logical table spaces what Oracle will think of. Now, whatever this user I created here, where is that one? Okay, create apps user. The default apps user assigned with this user table space. For that, you can go with the describe DB underscore users. We have username, and then we have what is that user account status. What is the default table space assigned for them? And then default template table space. Temp is your default template table space. So I'll just go with only default table space. Select my username, comma, whatever that account status just now we created. It should be open status. And then what is the default table space assigned for him? From DB underscore users, where username I'll check it for only apps. Why did not displayed? Make it small. Run it. Column username format A10. Rerun that. My username apps account is opened. We just now created. For that apps user, default table space is assigned with the users. So whatever this apps user, I'm gonna grant DBA to apps. So I'm gonna connect with that apps user, connect apps, password apps, show user, apps user is connected, and then this apps user is assigned with the user table space, and this user table space is assigned with this user.dbf, and whatever the apps user is going to create, like create table emp. I'm not going to create table. Let's say it's going to create table called employee, or let's create the table default. Let's see, create table emp, and inside that employee ID number, and then employee name or char 2 with the 15 letters, and then salary number 10. So apps user created this employee table. Select star from emp. So no, this is a brand new table, nothing is there. So if I do describe this employee table, this employee table has employee ID with the number 3 characters, employee name with the 15 character max, salary with the 10 digits max. So if this apps user connected to my database, he created this employee table. This employee table is reside under this user table space. This user table space is made up of this user.dbf. That employee table is residing under this user.dbf data files. And now that user apps user is going to insert into emp values, employee ID 1, employee name is Malik, employee salary is 1000. Comma is missing. Let one row inserted. Now you can do select start from emp. So one record is inserted into that employee table. That one record will be stored under this user table space, meaning underlining that user table space, whatever the data file, that will be user.dbf. In that data file, that one record will be stored. Likewise, this app's username and password, let's think of now this one is your bank, let's say I'll take one of the HDFC Bank or ICICI Bank or any bank, any Indian bank or any foreign bank. So what we did here in this particular lab one is your server and it has this instance and it has your database, data files. So what we did, we have created a user called apps user. And now let's think of this is your HDFC or ICICI Bank. So they have this application server. Give me a second, guys. All right, guys, sorry for that. Okay, so what I was talking, let's think of this is your application, this is your banking application, ICICI, HDFC Bank. So, like if you think of ICICI Bank, let's say how many user accounts in that ICICI Bank, right? You might be thinking, let's say how many branches for ICICI Bank in Bangalore, India, all over India, and even outside of India. Let's say around 2 million 2 million user accounts. I just give an example for this employee table. Like think of a ICICI Bank account table, like 1 million, 2 million record, like all those 2 million records, user account, user ID, user password, not password, user ID, user balance, user address, user information, like so many tables. 2 million records, what we are doing? Let's say take mine as example. Malik, I'm one of the ICICI Bank holder. I have my user ID, ICICI Bank user ID. I have my user password. So if there's a 2 million users bank account got opened, as a DBA, are we going to create a 2 million user IDs and user login passwords? If I create, what happens to my database? Database will blow up. Like, database will be flooded with all the user accounts. Then how it will be handled? Let's think of if it's not 2 million is fine. Like if it's a 10 million users account, are we going to create a 10 million user IDs, username and password? How we created this apps user? No. That all 10 million, 20 million, whatever the user account will be created on this application side here. There will be application server. And then if I open my ICICI bank account, my user ID and password will be created on this application server. I'll be getting my Malik user ID and Malik password at application server side. I'll open that ICICI.com banking web URL or mobile application. I'll log in with my username and password. I'll be connected to my application server, ICICI Bank application server. From there, if I do amount transfer, if I transfer my money from my one account to another account, so I'll be connecting to application server. I'll be doing the transaction at application side, and at the back end, this application server will be connecting to my database using this apps user and apps password. Similarly, let's say John is a one more user who has his own internet banking account. He will be connecting to his John username and password. He will be connecting to this application server. At the back end, whatever this John is doing a transaction, the transaction backend will go to my database using this apps user and password. Let's say that whatever the 10 million users who are connecting, they will be connecting to this application server, and via that application server, they will be doing their transactions. At the back end, when you query it, that if there's a 1 million records are happening at the moment, if you connect to your database and see all those 1 million transactions are happening through application user only. There's nothing called like 1 million users and 1 million accounts will be created under your database. No, all those 1 million account will be created under your application server, not at the database server. Be it anything, it may be ICICI or maybe think as a Walmart application or think it's your Amazon or Flipkart application. Whatever our user accounts, all those user accounts are created under application server side. At the backend, there will be one database user. Entire that application will be configured with that apps user. Whatever that we users, 1 million users who will log into Amazon application, all those user IDs and password are application side. Whatever the transaction we do, add item to cart, proceed with the payment, and whatever we do, all those transactions will be taken over by this apps user from the application server, and then send it to your database, and then save the transaction at your database side. Right, let's write what happened here. Like what we did a insert this employee, like as a banking application. Take this example as a banking application. I connected this Malik user and password to my banking application. I inserted, I put 1,000 or $1,000 to my account, and then my Malik user and password my application server connected to this apps user, and then went into my account table here in this database backend and inserted this 1 million or $1,000 into my account. Right, as a DBA, when we troubleshoot, when we connect to my database and see how many users are connected to my database, all I can see is apps user, hundreds or millions of connections. And then where they are connecting, you have to track it from the application side, which application they are connecting, and then what all those are doing it. Right, so that's a quick brief update on how these transactions will be works, and then how this visualization look like at the back
So
end
will you
to the
explain,
front end.
excuse me, will
Yeah,
you
go
please
ahead.
explain once again the application user connectivity from application to application server and then database? Can you help it
Yeah,
to?
in simple definition, take Amazon application is the best example. You have your Amazon app, even I have Amazon app on my mobile, and everyone has Amazon app. Or you log into URL amazon.com, and then you can log in, you can create your username and password. All those username and password, like 100 million users are going to Amazon app, creating their account. Those accounts will be created under application server. Whatever the application server we have it, so those all will be created under this application server. Let's say I connected with my username and password to Amazon app. You connected with username and password to Amazon app. All those will be connected to this Amazon application. All our user IDs will be created under this application server. And then if I do any transaction, if I buy any product, or you buy any product, or you put for any exchange order, or you add any item to cart, whatever the transaction you do, all the transactions from this application server, this application will be connected to your database using one single user called apps user. Whatever the apps user we created as a DBA, we create this apps user, and then we give that username and password to application team. Whatever we created earlier, this apps user, right? Where is that?
Yeah, thank you. But one thing is, so when I'm connecting from a web to the application server, there is a one single user.
Right.
Suppose there are 10 people are connecting and they're all connected to application server, as you said.
Right.
Okay, but they are doing multiple different transactions from
Right.
for each one. So when the transactions are fetched from the database, so how this apps one single user can fetch the multiple records of each
That's
user?
your application logic, right? Let's say Malik user, Malik password, I entered, and then via that Malik user, Malik password, application user will take that connection and then connect to my database. Let's take this as ICICI Bank example. I connected with my username and password. Application user is going to take via application user connected to my database, and I'm doing an insert $1 million into my account, and then it has to go to my account ID, and then it has to insert into my account table. That is all your application logic. That's where our application team will come into picture. Application meaning it's not just for connecting end user to your application. That's your business logic will run here. At the database, can I run the logic? No, database is just a backend database storage. There's no logic over there. All the application logic has to be built on your application code. This Malik user, whatever the transaction is doing, backend application user will take that connection and establish the connection to my database here. It's going to have a write access permission to only that Malik account into that Malik table data. And it should not write into that John table. Whatever the money I'm putting into my account, it not should go to John. That all logic will be built on your application layer here, not on the database side. So if there's no proper logic on the application side, it may end up with invalid data writing to some different table and messing up your data.
So just for an example, in the Oracle apps, if you suppose if you, in the Oracle apps, if you create a user, so that user, creating a user in the Oracle apps is not directly connected to database. It's not created in the database.
No. Whatever, that's the best example I told, right? Your Amazon app, all over the world, whatever the Amazon accounts we have it, it's not on the database side. If you create those many 1 million, 2 million, 10 million record in your database, you will end up with your database slow performance. Only one user at database side, which will interact with your application. Whatever you do, any banking application or whatever you do, everything will be application side.
So the apps user is the only one you create for the database.
Right. That's correct.
Okay.
All right.
Okay, thank you.
Move on now. Now we understood about physical logical structure, how the end user data flows, how the end user data will be stored. This is all fine. Now coming to now coming to this one, like now we'll go a little bit on the backup and recovery part. Like now if I go in depth, try to understand table space, segment and all, it's not going enough. Now this is one part. Like now we understand about the architecture. Now we understand about how the user data will be stored, how my database will be visualized as a logical structure and physical structure. It's all looks good as the visualization. But now second important point for DBA is how you can manage or maintain or backup and recovery. So manage and maintain is straightforward, whatever we told. Make sure that your instance is available 24/7. Make sure that your storage is available 24/7. Make sure that whatever the apps user is created, that user table space has enough space and all. So those all our management and managing, administering our database day-to-day activities. But one of the most important point at the DBA is backup and recovery, and followed by your performance tuning, and then performance tuning. So very first part what we talked about here is manage and maintain. And the second aspect is your backup and recovery. And the third aspect is your performance. So those are your three powerful areas where the DBA. So manage and maintain is whatever we talked about, like starting from the installation, administration, making sure that your instance space, user creation, and checking those permissions, making sure that enough space is available. All those are our day-to-day activities, what we talked so far. Once you do that one, that's not more than enough. Regularly, you have to have a backup, and then in case of any crash happens, you should be able to recover those databases. And then, and most powerful step comes after this backup and recovery is your performance tuning. So it's not like I just created my database, created users and connected to application, my application transactions are happening. No. Performance tuning is one of the most critical aspect of DBA life. It's a never ending story. We have to be keep learning every day and then keep assisting on that one. Meaning whatever I just give an example, like Amazon app is one. I logged into my Amazon application, I placed an order, I submitted it, and then that runs forever. As a user experience, moment I submit my order, within fraction of second that order has to submit, and that order request has to go to my database, store the data, and then come back to that end user, come back to me, and then say your order is confirmed. So that is a performance. Like if I submit order, then I get a response tomorrow, your order is confirmed. Then what's the point? So manage and maintain is what we so far discussed. From the creation of your database to administration and to the making sure that your database and space and all the users permissions, everything is available 24/7. That's our day-to-day activities. DBA has to do this one. Once that is done, then comes backup and recovery. Meaning whatever we did here so far, like my lab one, In this lab one, we have this instance, and then we have this database, data files. Make sure that your database is secured. And in case of your database crash happens, whatever I talked earlier, instance crash happened. The committed or uncommitted transaction, your S1 will come into picture, and then you're gonna read that redo logs, understand what is the committed transaction, what is the uncommitted transaction, and then bring your database back online. But what I'm talking about, your database, data files, whatever the system, sysocs, undo, user temp, whatever you stored here, those data files are secured or not. Whatever the mount point you stored that data, if that mount point is crashed, what happens? Let's say I put all my data here. Right, all this system, sysocs, undo, user, all are kept under this user on mount point. If this user on mount point is crashed, your entire database will crash. The entire business will be down. So for that, keeping our regular backups is one of the key DBA aspects. So we use something called RMAN tool to take backup. To take backup of all data files, take backup of all log files. So we're going to use this RMAN tool to take a regular backups. And in case of anything crash happens, like what I talked about here, this data files, system data files, sysoc data files, undo data files, user data files. Temp is again, as I mentioned, temporary. You don't need to take a backup or you don't need to restore that. It will not be having any actual data. What is the actual data is holders? Your system sysocs, undo, and users. If any of the data file is crashed, you should be able to restore them using these backups. One of those aspects. Why you need this backup? Very first use case. Use case 1. In case any crash, we should be able to recover it. In case of any crash of a single data file or entire data file, entire database, we should be able to recover it. When we should be able to recover it? If we have valid backups. Not a use, that's a user, is a use case 1. Then the other use case. Best example what we talked, the application logic. When a user connected to application, ICICI Bank application, he do any transaction from the application, it has to go to that apps user and connect to a database. It has to do only that Malik user account table only. It should not do it in the other users. For that, your application logic has to be very, very powerful. Your application logic has to guide that instruction. So if you want to change your application logic or you want to build some enhancement in your application, can you directly implement it in your application production database or production application? No, right? You have to first test it in your development, and post that you have to test it in UAT or test it in test database. Once everything is works fine, then you have to deploy that same application change on your production database. For that, you need to build your development or test database similar to your production. Build, dev, or test or UAT database using prod backup. Sorry. So you have to have a proper production backup. Using those backups, you can build your test and dev UAT so that application team will change or enhance their application logic, or new enhancement, new feature will come into picture for that application side. Once you test successfully and test dev UAT, then you can go for deploying into your production. These are the two main use cases. One is a real crash happens. You should have a valid backup to bring your database back online. And the other use case is to build a lower environment, dev test UAT from the prod backup so that your application team can test that new feature functionalities. Right. So this RMAN tool is default, comes with your software, Oracle software. Oracle software gives this Armen tool. You don't need to separately install this Armen tool. Armen tool is one of the built-in utility with your database software. You just need to run this Armen target slash, sorry, Armen target slash. They're going to take you to your Armen command prompt. You can take whatever backup you want. You want to backup your all the data files, or you want to backup your all the transaction logs. The transaction log is nothing but your archive log. Again, I'm not going to talk about that archive log and all. Just think of whatever we talked about, that redo logs. So everything will be possible with your Armen. Again, when it comes to Armen, we have Armen level 0, level 1, and so many other stuff. Archive log backup and Armen retention. That will be your Armen retention policy to redundancy, recovery window. And then again, it comes to Armen. What is expired backup, absolute backup? So many things about the Armen. But at a simple definition about the Armen here. So when you understand about this database maintenance and administration task is done, so regularly taking a backup is one of our DBA task. So especially on Sunday, we take level 0, that's a full backup, and then weekdays, and especially that will be Monday to Saturday, we take something called level 1. Level 0 is your full backup. On top of the level 1, level 0, you can take level 1 incremental backup, the delta changes. And then plus regularly take archive or transaction log backups. Regularly take your archive log or the transaction log backups every 4 hours or every 5 minutes, or every 4 hours or every 6 hours or every 12 hours, based upon what is your FRS size and all. But again, I'm not going to give any demo on that, but I wanted to give the overview of this one, what exactly mean by backup and recovery. In olden days, we used to have that cold backup and hot backup and all those things. But nowadays, in 9i, 8i and all, we used to use it. But now there's nothing called, nobody uses that cold backup or hot backup. It's all about Armen. And again, now in recent technologies, we have something called snapshot based backup. You don't need to take your Armen backup, just a OS level, they'll take a snap based backup. That's a different storage level concept, but don't go into that. Once you regularly set up your backup and recovery policies, you have proper backup, then you can make use of those backup for any of the recovery scenarios, or to build any of your lower environment. All looks fine. And the last aspect for the DBA is your performance tuning. And
Alex, just 1 minute. Just before that,
yeah,
the backups, as you said, level 0 is the full backup which we take on Sunday, and level 1 is the one next incremental backup. So incremental backup and cumulative backups all are in the level 1 only.
not incremental. In level 1, you have a cumulative plus differential backup. Based upon that, you have to think what is your need, whether you want to go for cumulative type backup or differential type backup. So if you ask that one, simply I can draw the diagram. Let's say Sunday, let's say Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, again here Sunday. Let's say Sunday I'm going to take level 0 backup. That will be our full backup. So from Sunday to Monday, there's some transaction. Let's say 1 GB data changed. From Monday to Tuesday, again 1 GB transaction happened. From Tuesday to Wednesday, again 1 GB. And Wednesday to Thursday, 1 GB data change. These are new transactions end users are doing. Thursday to Friday, 1 GB transaction. And Friday to Saturday, again 1 GB transaction, they're doing it. When you take a level 0, that will be full backup, you're taking it on Sunday. On Monday, Tuesday, Wednesday, Thursday, Friday, Tuesday, when you take this differential, every day you're going to take 1 GB backup. Whatever the daily change transaction, that's your differential. It will take every day 1 GB transaction data change. Instead of everyday differential, if you go with everyday, this is all your level 1. Instead of differential, if you go with a cumulative, what happens? Cumulative will always take it from level 0. If I take a Monday level 1 cumulative, from Sunday to Monday, it will take 1 GB. So on Tuesday, if you take level 1 cumulative, it will always take it from level 0. From Sunday to Monday, Monday to Tuesday, 2 GB data will take. When you take Wednesday, level 1 cumulative, again go back to Sunday, level 0. From level 0, Sunday to Monday, Monday to Tuesday, Tuesday to Wednesday, it won't take 3 GB. So think of cumulative will always refer to your level 0. Differentially doesn't matter. Just take previous point. From there, whatever the daily change, you can take that backup. You can define it while taking a level 1 backup, what type of backup you want it, cumulative or differential. But level 0 is full backup.
So perfect. Perfect. So level 0 is a must to have a level 1 backup. Is that correct?
If you miss level 0, like I don't have any level 0. On Monday,
Okay.
you take level 1, cumulative or differential, that internally runs level 0. Level 1 is not
Oh,
mandatory. Without level 1, you can directly, without level 0, you run level 1, cumulative or differential. That Mondays, it will show it as a level 1, but it will be a level 0 internally.
oh, if you take it, so that means suppose my level 0 backup is gone and I have a level 1 backup on Monday. So can I recover the database with that?
Yes, that level 1 is your level 0. Even though when you do a list backup, it's going to show that level 1 backup, but that will be a level 0 at the back end. And if your database is 10 terabyte, level 1 backup will be 10 terabyte in size. You can recover it.
Okay. Got it. Thank you. Sure.
All right. So once you have a strong backup, then you should be able to recover your database in case of any crash. You should be able to build your lower environment for any business testing and new improvement. And once that is all done, one is the most performance activity what DBA will do on regularly day-to-day basis. And it's a continuous learning effort, not necessarily 1 day learning, 2 day learning. So every day we have to keep enhancing our performance and learning this performance tuning. And how you can do it, that's all left to you. It's not a 1 day learning or 2 day learning. You have to be every day keep learning on the performance tuning part and keep enhancing your knowledge and why it happens like that. You have to ask your question yourself and then discuss that. That's how you can make improve in yourself on the performance tuning matter. So one of the common interview questions what you can get, uh, my query used to run 10 minutes, but last 1 week it is taking 1 hour. This is one of the most commonly asked interview questions. Again, I'm not going to talk about performance tuning. There will be so many things to talk, but this is one of the most commonly asked interview questions. You can get it. But what is your ideal way to approach this one? What is your way of troubleshooting when they ask my query, select query used to run for 10 minutes, but now it's running for 1 hour? Very first thing is this server side issue? Is this database side issue? So if it's a server side issue, we check few basic checks, top command, vmstat, iostat, and then your memory check and sar command. So many tools. Or even you can use your ready-made tools like OEM or Nagios, right? Server monitoring tools. Or
Sir,
even if Oracle provide you something called OS
sorry
Watcher.
sir, Nagios is free one?
No, Nagios is licensed one.
Okay, thank you.
Even you can use the Oracle provided free software called OS Watcher in normal on-premises server. You have something called Exa Watcher. It's for Exadata machines. You can install this software in your database server, you can, which will give you a graphs about this, all the server load, server performance, how it was going through. Very first thing is whenever the query is running bad, then quickly check on the server side using dynamic commands or using any of the OEM tools or Nagios, the UI graphs, or you have configured with ExaVoucher or OS voucher graphs, you can use them. See your server is getting spiked up at particular time when that query ran. If your server is fine, no issue on the server side, then you can jump onto database side issue. Is it database is the culprit? Database is causing this query performance issues. So if database side query performance issues are coming, very first thing what we can check is my database is up to date patch level. Oracle will always recommend you to, Oracle will provide you quarterly patches. So typically Oracle will provide you patches on Jan, April, July, and October. So we have to keep updating these patches up to patch level or at least n-1. Right now it's a May, so next patch will be a July. So already April patch is out. So you have to be always apply this April 2016 patch or n-1, one patch before that, Jan patch, it has to be there. Because these patches are lot of bugs, lot of improvements, lot of enhancement, lot of vulnerability fixes, lot of security fixes will be included on these patches. It's highly recommended. Even if you have any query performance issue or any issue on your database side, when you engage Oracle support, very first question they will ask you, is your database is up to date patch level or not? Give me ls patch inventory output, I'll check it out. If that is not up to date patch level, that first they will push back to first apply the patch and come back to us. Right, once that is done, once your patches are up to date, still your query is not performing well, then what you're going to check, what all the tables involved in it. What all the tables involved in that query, whatever that query that supposed to run for 10 minutes, taking for 1 hour. Let's understand what all the tables involved in that. And are those all the tables, whatever is involved in that query, gather stats are done or not? And then next, when the table involved we identified and the gather stats are done or not. If not, go ahead and then do first gather stats. Your query will be automatically runs normally. What are all the indexes involved on that query? Very basically, we create indexes on those tables, whatever the tables involved, right? So are those indexes gather stats on table, gather stats on the index? What are all the table involved on the query and what is the stats status? What are the table involved in that query and what is the stat status? Same thing. What are all the indexes involved on that query and what is the index status? Rebuild index. Like we have two options, online or offline. So this is your one step-by-step approach for how to handle this particular questions asked in interview. This is one of the most commonly asked question in most of the interview. Right, server side performance is done no issues found, and jump onto database side, check the patch level, check what all the tables involved in that query, and do a gather stats, check what all the indexes are involved in that query, do a index stats, and check what are the table indexes involved and what's the status of that index. Is it visible, invisible, unusable? Based upon that, rebuild your index. And finally, what is the execution plan? Or before execution plan, what all the tables involved in that query, and what is the fragmentation on those tables? Again, fragmentation, I'm not going to explain here, but it will be too much big concept. You have to understand about your data blocks, and you have to understand about the row piece, and you have to understand about the high watermark. You have to understand about the row chaining, row migration. So big concept. So is your table involved in that query, or all those fragmented? If yes, those are fragmented, then do a table move, or do a table shrink, or do a export import. Ideally, we don't recommend export and import. But that's also one of the options. We always do table move or table shrink. Export import is not necessary. That also will bring that fragmentation down, high watermark down. Then once after that done, finally we go with the what is the execution plan or wrong execution plan. Go back to our very beginning. We talked about the when the query is executed, it's going to go for parsing. When the parsing is done, it's going to go for execution. Execution is the one which is going to retrieve the data. This execution is using a wrong plan. Let's say I have something called baseline. In my baseline, we have plan P1, plan P2, we have plan P3. So plan P1 is like 10 minutes. The query used to execute in 10 minutes. Plan P2 is query is going to execute in 30 minutes. And then plan P3 is the one which is executing in 60 minutes. So my optimizer, when it go for execution, it has to pick up this plan P1. That's where the expectation is. But wrongly, my execution plan is picking up this wrong execution plan, 60 minutes one. That's why the query is taking 1 hour. So we did all these activities. By this time, your query has to come to normal mode. It has to run it in 10 minutes. After doing all this, still that query is running with a 1 hour. Then it's a wrong execution plan. Your optimizer is wrongly picking up this wrong plan. Then we need to force optimizer to use plan P1 via something called SQL profiling. We have something called SQL profiling. With the help of SQL profiling, we are going to force that optimizer was go ahead and use this plan P1. Whenever anyone run this query in future, always use this plan P1. Right, and then finally, even after SQL profiling, still query running with 1 hour, plan P3 and taking 1 hour, then engage Oracle support. So this may be particular bug in your environment. Oracle may provide you a patch, and you have to apply that patch to bring that query into normal state. So that's your final options. So by doing this one, you should be able to get that query into normal mode or normal state. So again, this is a high level I gave here, but in a simple nutshell, how you can do all this. So there'll be multiple ways, like you can done dynamic performance views, like VDLR SQL, and VDLR long ops, and then VDLR sessions, and then many more things. Or you can go with your AWR report. By running this AWR report, you should be able to analyze it one by one. What is that query? What are the table involved? And then what is the execution plan? AWR report. This AWR report internally contain your ASH report and internally contain your ADDM report, and internally it contain your SQL tuning report, right? Many more things. Just run AWR report and analyze that report, and with that report, you should be able to conclude any one of this, and then go by one, and then you can able to fix that. Right. So this is about, again, there are few questions. I'll take a few questions here. Wait events and all. Like, I'm talking about performance tuning with respect to a query taking more time, meaning only the select query. This wait events and all will come into picture whenever you perform a lock, DDL lock, DML lock, and update queries and all. So insert query and all. If you do those all, those your wait event locks and all will come into picture. That's a different story. But it's a purely what I'm talking about. Your select query should not be hit by any locks or any waits. So wait event, if it comes again, there's a different story on that DB file scattered read, DB file sequential read, your buffer BG wait events and all. So I'm purely talking about your query, which is ideally should run and which is running more because of maybe gather stats on the table or index or whatever the index you used, which is not visible, or your execution plan itself is wrong. So then this will be your answer. So other way of troubleshooting is different point. That is, you have to look at your in the AWR report when you generate, look at your high level, what are the top 8 events. And if you don't see any top 8 event and all, directly jump onto this analysis. And the moment you see a lot of wait events, then those wait events are because of what? Because of your DB file sequential read, DB file scattered read, or your buffer BG wait events, or there'll be a NQ lock, your table lock, and then those are your DML operations. But for the select query, you can directly jump on this one. If you don't see any of those DB file scattered read or sequential file read, then start with this analysis. It should fix that issue. Right. There are a few questions. Let's spend few more time on that. Wait events. We look, okay, again, wait event is fine. Wait event is the one which will impact your DML operations, like update statement and all those things.
Sir, I have a question related to SGA, sir.
SGA, yeah, go ahead.
Sir, I have a 128 GB of RAM, and on database creation, I am using automatic shared storage management.
128 RAM in your Linux server.
Yes, sir. Yes, sir.
Okay.
And on database creation, I am using automatic shared storage management.
You have to allocate memory for your database creation. How much memory you allocated for your database?
That's the question, sir. What would be the maximum or idle amount of ASM to set?
Okay, got it. I'll take that question in a minute. I'll explain that one now. I got it. Okay. Can we manually catch SQL query? We already told yes, you can do that. Local temp table space, yeah, local temp table space, local undo table space. Again, those are the few more concepts you can understand that. We have a local temp table space, we have local undo table space, and temporary undo table space. Recovery steps. Okay, recovery steps again, they're not easy to demonstrate and explain it. We're not going to talk recovery. Block corruption is also one thing. Okay, fine. Those are like advanced one. Those will not be taken because if I start explaining, it will be too much. Okay, so hope this is clear. Performance tuning, how we can analyze and how we can answer it for one liner. Uh, Now let's take that question. What Lalit is asking, let's say I want to design my brand new database. This is my lab one. So which has 128 GB RAM. how much, like, my intention is to create only one database instance and one database. How much in that instance, what I talked about is SGA and PGA plus background process, right? So this SGA and PGA, how much I can allocate? That is again one of the interesting questions in most of the interview. So that comes with the two concept. How can I define out of this 128 GB, how much I can allocate SGA and how much allocate for my PGA? So let's say you have to always go with this, like it's a RAM. This RAM is now 128 GB. So you have to always go with a thumb rule called 80%, 20%. 80% for your database and 20% for OS. So in a simple, make it simple, I'll not take 128 GB. Let's for the simple math calculation, make it as 100 GB. So you have a server RAM with 100 GB. You have 100 GB RAM in your server. Out of the 100 GB, you have to assign 80 GB for your database and 20 GB for your OS. 20 GB for your OS operation and 80 GB for your database operation. Out of this 80 GB, what type of database you are installing here? This database type it matters. Is it OLTP? Is it OLAP? OLTP is your online transaction processing. OLAP is online analytical processing. It's easy your data warehouse, the huge databases where only select query runs. Here it's a OLTP, like online transaction, your banking application, retail application. So if it's a OLTP, your SGA and PGA. If it's a OLAP, your SGA and PGA. If it's a OLTP, again you have to assign 80% of your memory into SGA and 20% of memory into your PGA. If it's a OLAP, it will be 50-50. 50% here, 50% here. Or you can go with a more 50, like 40% SGA and 60% for PGA. For your OLAP, your PGA should be more. For OLTP, your SGA should be more. So it should be out of 80 GB, you can assign 80% of that for SGA, 20% for your PGA. If it's a OLAP, you can go with the 50-50%, or you can go with the 40% of 80 GB. How much is that for SGA? And 60% of that 80% is for your PGA. So you have to first define how much is your, give me a second. Where is that? You have to define your OS memory and database memory, and in that database memory, what type of database is it a OLTP and OLAP? Based upon that, you can again further calculate 80-20 or 50-50, or even go for 40-60 SG and PG. That's your thumb rule of calculation. Again, this will be a part of your solution architect who will decide this one, because we don't know what type of database, how many users are connect. As a junior DBA or senior DBA, I will not be in a position to analyze this, define this memory until unless I work with application team and understand that application, how many users are connected, what kind of a transaction they will do. It's all part of your solution architect who will be deciding this all memory and parameters for the very brand new project or brand new installation. Right? Hope that's clear. Or any questions, guys, so far? I tried to cover it in a brief manner for the database, starting with the managing administration, backup recovery, and then the
Are you
performance.
going to start any performance tuning course in future, sir? Actually, I am waiting for a long time.
Yeah, no, right now, no, I don't have any plan, but probably if need some guidance or some materials, I have ready materials. Probably I can ping you in WhatsApp. You can just ping me in my WhatsApp. I'll share few
And
documents. You can just
okay,
glance
sir.
through.
Okay, sir. Thank you. Hi.
All right. With that, I'm gonna wrap it up. Provided if anyone has any questions, we can spend few more minutes. Otherwise, we can wrap it.
Malik, sorry for my disturbance, Malik, but
Yes.
people are not discussed here. Restore point. So restore point. Just I have a small doubt on the one of the parameter. Why you people are using for the no file name in a restore point? I think it may be
No file name check.
yes, correct.
So no file name check when you do a restore or when you do RBN duplicate. So whatever the backup piece you took, and those backup piece will be having your source database file system structure, where your source database has that all the data files are located. The moment you specify no file name check, don't verify your backup pieces and associated data files where they're located. Directly use those backup pieces and then proceed with your restore activity. Let's say your production database has 10,000 data files which are located in a U01 location. You took a backup of them and then you submit your RBAN duplicate with no file name check, meaning, boss, whatever the backup I took, I know my production data files are located under U01. Don't verify those 10,000 data files locations physically on my target. Directly use that backup basis, proceed with your restore activity. If you specify that no file name check equal to yes, or if you specify that without no file name check, then what happens? All those backup pieces you took, first RMAN will try to check whether that data file exists or not on the target side. We know that it already not exist, but there's no point of checking that one. That won't take, let's say, if it's a 1000 data file, it may take 5-10 minutes. If it's a 1000 data file, it may take 30 minutes, 1 hour. If it's a 10,000 data file, it may take 3-4 hours. I don't want to waste that 3-4 hours of time unnecessarily checking the target data files. Because target database is a target server, is a brand new server. I know there's no file over there. Don't spend time unnecessarily wasting checking that files on the target server. That's a use of no file name check. Blindly use that backup pieces, proceed with the restore activity. Always use that no file name check. That's gonna save you 3-4 hours of time if it's a huge database.
Okay. Thanks, Malik. Thanks.
All right, we are right on time, guys. Let's take a break. If no more questions, we'll surely come up with a few more live sessions, especially for RAC and other performance tuning kind of stuff. Stay tuned for them. We'll be launching few more sessions in future.
Malik, one more question I have it regarding the data card. Actually, see, we have a physical standby, logical standby, and data. These are all the types of we have. Actually, see, in a physical standby, default is the mount. Other is read and write like that. I think maybe default write means we have to there the people are enable some parameters, or default it will be mount. What should how we will be considered regarding this thing?
So you have I think again it's too much to talk.
Okay.
Default is physical standby, and your 99% of all the client, it has to go with the physical standby database, because that's the physical standby database which will support your DR scenario, DR drill. In case of anything, the real disaster happens, then physical standby database is the one which will be the guaranteed one. Other than that physical standby, if you go with the logical standby or snapshot standby, which is not guaranteed, which is not exactly same as your production copy. Use physical standby is the only one which will be having a equivalent data of your production. Other than that, physical standby, logical standby, or snapshot standby, which will not be having your exact production copy, you may end up with the data loss situation in case of real disaster happens. So again, there are a lot more to think how to convert that physical to logical, or physical to snapshot and snapshot to physical. There'll be too much to show the demo and talk, but for now, your physical standby is the default one, which will be in a mount mode, and which will be most of the time will be in sync with your production.
No. My question is, Malik, physical standby, actually people are using for the DR side, DR activity side. But
Right.
actually, see, the mount point I am saying you, the default is the mount, right? Mount stage, right?
Your
Actually, see,
physical standby will be in mount mode, and your snapshot standby will be in read write mode, but your snapshot standby will not be in sync with your production.
yes.
So you should not run your disaster recovery with a snapshot standby. In case of production crash
But
happens,
standby should be in a no mount. Standby should be no mount mode, right? Always.
no. You have a 3 types of standby. In a simple definition, again, this will be one of your interview questions. What is standby database? What are the different types of standby database? three types of standby database: physical standby, logical standby, and snapshot standby. Physical standby is in mount mode, and snapshot standby is in read-write mode, and logical standby is in open mode. So physical standby is in mount mode, it will be exactly in sync with your production. In case of production crash happens, you bring your physical standby as a new production. If your standby is a snapshot standby is in open mode, but which will be lagging behind your production. In case of production crash happens, you cannot use that snapshot standby as your new production, because your new production, your snapshot standby will be having a less data than the production, because production will not be in sync with your snapshot standby. And coming to the other one, logical standby. Logical standby is also in open mode, but logical standby will be having a more extra data from the production. The moment production database crash happens, and your snapshot standby database will be acting as a production one, but that production database is not guaranteed that it has exact data of your production. There may be some less data, or somebody might have deleted the table, or something happened on your logical standby side. That's why this logical standby and the snapshot standby is not meant for your disaster scenario. Only the physical standby is meant for your disaster scenario. In case of crash happens, physical standby will be acting as your new primary. That will be in a mount mode. Mount mode is your default mode for your standby database. All right, yeah, a lot more to cover on the standby, but let's keep it short for standby side. I not covered anything on that. All right. With that, let's take a break, guys. We'll continue with the next classes with a few more topics. Stay tuned until then. Thank you, guys. Take a break,
Thank you,
guys.
Malik.
Thank you.
Thank you, Malik. Thank you.
Bye. Thank you all, guys. Bye. Take a break.